Thank you, good people. I just joined the department a couple of months ago, and this is a project I did while I was still a student 2 years ago. Good people, land uses around the globe are known to be major donors of nutrients to aquatic systems where they cause eutrophication. Eutrophication is defined by aquatic scientists as a situation in which aquatic systems become enriched with nutrients such as phosphorus and nitrogen from both internal and external sources. The major external sources of nutrients to these systems are agricultural practices and urban development. Let us now zoom down to agricultural practices. In the case of agricultural practices, we have land-based fish farmers that use both organic and inorganic nutrient loads to maintain their stock. We also have crop and tree plantations where farmers apply fertilizers, pesticides, and herbicides to increase their yields. But the problem with the application of these compounds is that if these elements or compounds are not absorbed by the targeted species, and they often do end up in rivers after rainfall, or they are blown out by winds and end up to rivers as particulate organic matter or leach down to groundwater. In the case of urban development, we have a problem of waste treatment plants that sometimes discharge raw or semi-treated sewage to river systems. We also have a problem of human settlements with no proper sanitation. As it has been pointed out in Swartkoop and Ezemvelo rivers in the Eastern Cape to be major contributors of heavy metals. Once all these nutrients reach aquatic systems, they become limiting factors for primary producers, thereby increasing primary production. Algal mass or causing growth of macrophytes. As you can see there in Umtata River, the macrophytes have covered the water column. That also leads to losses of anoxia, which might cause fish kill, water deterioration, and loss of value to properties closer to these systems. So the effect of these nutrients can be investigated using stable isotopes. Isotopes form two or more forms of the same element that have the same numbers of protons but different neutrons. So if they have the same number of protons but different neutrons, this means that they have different atomic masses. As you can see here for nitrogen, they have different atomic masses. Nitrogen 15 is heavier than nitrogen 14. And if the nitrogen 15 is heavier, that means it is the most preferred element by the plants because it can be incorporated in the tissues of organisms and be stored for a longer period of time. The other important thing here when we're talking of stable isotopes is that stable isotopes can be used to trace sources and sinks of nutrients. And the other important thing is that because the compounds that are produced from within river systems are nitrogen poor and isotopically depleted than the ones that are derived from outside the system. This means that these elements are transported with little or no modification to these systems. We wanted to apply that to use nitrogen stable isotope in Umtata River because the river is under pressure due to different land uses which include agricultural practices and wood treatment industry in the upper reaches. There is dam there in the middle reaches, and a waste treatment waste treatment plant in the middle reaches. The river is used by local people for different reasons. They use the river for swimming, fishing, and also for domestic purposes. We selected 7 sites along the river. The sites represent the different stages of the river system and different land uses that were occurring within the catchment of the system. So we wanted to, because the system was found by Fatoki et al. In 2001 as a polluted system, we couldn't rely on heavy metals because most of these metals are not biodegradable. So they are not required by these living organisms. So we wanted to use an element that is required by these organisms, and the element that can tell us the amount and concentrations of essential elements within the system. So we used the stable nitrogen isotope of macrophytes as possible indicator of the ecosystem function. We also wanted to check the effect of sampling sites, the sites that we selected, and sampling seasons, and to relate the signatures of nitrogen-15 to land uses that were occurring within the catchment or around that we selected. We chose macrophytes because macrophytes are stationary, and many of them are rooted. That means they are in permanent contact with the water column and sediments. Because they can live for a longer period of time, they can tell us changes in nutrient concentration over time. And the other important thing is that when you are processing these macrophyte samples, you don't have to spend a lot, and the samples can be stored for future references. We handpicked macrophytes along as we selected. We transported them to the laboratory. We identified them down to species level, and we prepared them for isotopic analysis. We recorded about 26 species of macrophytes with about 14 families. And the nitrogen-15 signatures that we got from the macrophyte samples were introduced into two-way analysis of variances, and to test the effect of sites and sampling seasons, sites and sampling months, and all the tested variables were significant with varying degrees, that you can see from the table there. Good people of the world, what we got is that in the upper reaches, the signatures were lower than 3 parts per thousand. And the dominant land use there was agriculture. This indicated that the nutrients were from detritus from the tree plantation in that area. But the signatures were a bit enriched compared to Site 1. And that site was positioned to such an extent that it could reflect the effect of the wood processing industry, which was 100 meters closer to that site. And it did just that. But coming to Site 3, where the land use, the dominant land use was sand mining, the signatures were slightly depleted compared to Site 2. And we attributed that to sediment, to the fact that when the silt is washed towards the system, the sediments change, and the change in sediment leads to losses of nutrients as the sediments, the silt have loose particles. So they are the dissolved ions within the system, which very easily in between the particles, giving no chance for macrophytes to assimilate enough as they would if it was a different type of sediment. Coming to site 4, where the dominant land, where was a dam, the signatures were enriched compared to other sites above, and that was attributed to the fact that water current in dams is slow, that is giving enough chance for dissolved particles and suspended particles to set down and be absorbed to sediments, thereby increasing in concentration. Coming to site 5, where there was a sewage discharge, the signatures were higher, indicating the effect of the sewage discharge, but the signatures were very high, where we never expected them to be. That was at site 6, where the dominant land use was grazing. So we attributed that to the fact that maybe the nutrients that were discharged at site 5, the sewage, the nutrients, they were not biologically available to macrophytes. They had to be transformed by bacteria or any other organism that can transform the nutrients into a form that plants can assimilate. And the decline of nitrogen-15 towards site 7 was attributed to the close proximity of the site to coastal system. This coming to seasonal variations of baby isotopes along Umtata River, we found out that winter had the highest values of signature of nitrogen-15, and we attributed that to high nutrient concentrations in winter, and to the fact that the former Transkei area of South Africa is known to have winter dry conditions. The signatures decreased from winter down to autumn, and that was also now my English is gone. Was attributed to ecophysiological adaptations of macrophytes to seasonal changes, and to the fact that macrophytes respond differently to seasonal changes. We had that low peak there at site 3. So, based on the signatures we recorded, we concluded that the system was eutrophic, especially in the mid-lower reaches of the system, where the signatures exceeded 10 parts per thousand, where in Europe, Asia, and North America is regarded as the standard for freshwater quality. And we recommended that a continued monitoring be done that may ultimately come up with management options for the communities living within the study area. Good day, I thank you.